Hello everyone! Today we continue with the third part of the chapter on concrete materials. I'm your lecturer for today, Miss Liu Ting. The main focus of the third section is on the technical quality requirements for stone. Stone primarily refers to coarse aggregates, which are aggregates with a particle size larger than 4.75 mm. They are categorized into pebbles and crushed stone based on their source of production. Similar to sand, they are also classified into classes 1, 2, and 3, based on technical requirements. Class 1 is suitable for concrete with a strength grade greater than C60. Class 2 is used for concrete with strength grades ranging from C30 to C60, as well as for requirements such as frost resistance, impermeability, or others. Class 3 is intended for concrete with a strength grade less than C30 and a construction mortar. The quality of stone can be assessed from 7 main aspects, including 1. Apparent density, bulk density, void ratio. 2. Clay content, clay lumps, and fine particle content. 3. Needle and flake particle content. 4. Content of harmful substances. 5. Strength. 6. Soundness. 7. Particle grading and maximum particle size. Now, let's discuss the technical performance based on these 7 aspects. First, let's consider the apparent density, bulk density, and void ratio of stone in concrete materials. The requirements are similar to those for sand, with the following criteria. Apparent density, more than 2,500 kg per cubic meter. Loose density, more than 1,350 kg per cubic meter. And void fraction, less than 47%. Regarding clay content in stone, it refers to particles with a diameter smaller than 0.075 mm. Clay lumps and fibrous particles content refers to particles with a diameter larger than 4.75 mm that, after water washing and pinching, become smaller than 2.36 mm. Specific technical indicators are as follows. Clay content should be less than 0.5% for Class 1, less than 1.0% for Class 2, and less than 1.5% for Class 3. Clay lumps and fibrous particles content should be 0% for Class 1, less than 0.5% for Class 2, and less than 0.7% for Class 3. The needle and flake particle content in stone also have specific requirements. Needle-shaped particles refer to particles whose length is greater than 2.4 times the average particle size of the category, while flake particles refer to particles with a thickness less than 0.4 times the average particle size. Needle and flake particles are not only prone to breakage, but also increase the void fraction of the aggregate, leading to reduced mix compatibility and lower strength. Specific content requirements are shown in the table. Needle and flake particle content should be less than 5% for Class 1, less than 15% for Class 2, and less than 25% for Class 3. In general, stone should not contain impurities such as pebbles in crushed stone or debris like grass roots, leaves, twigs, plastics, coral briquettes, and slag. The content of harmful substances varies depending on the stone category. Specifically, the content of organic matter should be qualified for Class 1, Class 2, and Class 3. Sulfides and sulfate content should be less than 0.5% for Class 1, less than 1.0% for Class 2, and less than 1.0% for Class 3. The strength requirements for stone mainly involve two indicators: rock compressive strength and crushing index. Rock compressive strength is determined by making cubic specimens of the parent rock measuring 50 mm times 50 mm times 50 mm and marrying their ultimate compressive strength under water-saturated conditions. The crushing index involves loading a certain mass of air-dried particles with size between 9.50 mm and 19.0 mm into a standard mold, applying uniform pressure on them to 200 kN at a rate of 1 kN per second, sieving out fines using a 2.36 mm sieve after unloading, and calculating the index using the formula. The formula includes delta A as the index value, MO as the specimen's mass, and M1 as the mass of the specimen after the crushing test. The crushing index for crushed stone and pebbles is shown in the table. For Class 1, 2, and 3 stones, the maximum allowable crushing index for crushed stone is less than 10%, 20%, and 30% respectively. And for pebbles, it should be less than 12%, 16%, and 16%, respectively. The soundness of stones refers to their ability to resist rupture due to natural weathering and other external physical and chemical factors. For coarse aggregates used in concrete with frost resistance requirements, soundness testing is necessary. Soundness of crushed stone or pebbles is determined using the sodium sulfate solution method. After 5 cycles, the weight loss of the specimen should meet the requirements specified in the table. For Class 1, 2, and 3, the mass loss should be less than or equal to 5%, 8%, and 12% respectively. To reduce void ratio, improve concrete mix compatibility, and enhance concrete strength, cross aggregates also need to have a well-graded particle distribution. There are 2 types of coarse aggregate particle grading: continuous grading and intermittent grading. Continuous grading involves a continuous size distribution from small to large, while intermittent grading directly matches small particle sizes with large particle sizes, resulting in discontinuous grading Intermittent grading should be used sparingly due to the potential for segregation. In addition, the upper limit of the nominal grain size of coarse aggregate is referred to as the maximum particle size for that grade. From a structural perspective, according to regulations, the maximum particle size of coarse aggregate for concrete should not exceed 1/4 of the minimum dimension of the structural cross section and should not exceed 3/4 of the minimum clear spacing between reinforcement. For solid concrete slabs, it should not exceed 1/3 of the slab thickness and should not exceed 40 mm. From a construction perspective, for pumping concrete, the ratio of the maximum particle size of coarse aggregate to the inner diameter of the delivery pipe should not exceed 1:3 for crushed stone, 1:2.5 for pebbles, 1:3 to 1:4 for high-risk buildings, and 1:4 to 1:5 for super high-risk buildings. For an economic standpoint, when the maximum particle size is less than 80 mm, cement consumption increases as maximum particle size decreases. However, once it exceeds 150 mm, the savings in cement become less significant. That concludes today's lesson on the technical quality requirements of stone. Thank you, everyone.